sure this can advance. These things never go quite as smoothly. There we go. Okay, as you'd like. So I wanted to start with a bit of background and sort of the empirical research base that really underpins what I'm talking about today. So the main thing is a study that is called Aspires, and I was the researcher on the first Aspires project and then have been involved with Aspires 2 and Aspires 3. And it sort of started in 2009 and is still effectively running today. It's a longitudinal study, as well as being sort of a cross-sectional study, but of that cohort as they get older, of young people's science and career aspirations. And so when we first met the young people, they were 10, turning 11 at the very end of primary school. And for Aspires 3, they were sort of 21, 22 when we were collecting that data. And they are now, I guess, about 23 or so years old, give or take. And it's involved large scale surveys, which were cross sectional, given at 6 different time points over the past years, and sort of in the end of primary, as I said, and up through secondary. And those were of the cohort; those were cross sectional, alongside in-depth qualitative interviews, which were properly longitudinal. So to give you a sense of the scope of this, we have, I want to say, around or slightly over 50,000 survey responses from that age group, as well as, and then in terms of interviewing the young people and their parents, we started with 92. And we aimed by the end of Aspires 1 to have 40, but at our last count, it was around 50 who we've managed to interview at 6 time points over the past, 14 years or so. So it's quite a robust data set, I should say. Alongside that, we had Enterprising Science, which was sort of a sister project, a research and development project that really aimed at looking at and better understanding the factors that influence science engagement. And it also involved the development and testing of approaches for engaging students from more diverse backgrounds. And so that also informs some of what I'm talking about today. So the key themes and findings that have really come out of this research are that, and we're not the only ones who have found this similar things, I have to say, but that lack of interest in science is not the main problem. And I don't know about in Sweden, but in the UK, certainly, as well as in the US, there's a lot about, we need to get kids interested in science, excited about science. But that's not really the issue. If they're interested, then they'll keep on doing it. But that's really not what seems to be happening here. And there's also a relative lack of change in terms of the percentage of people who aspire to go on to become scientists or work in science from the age of 10 up to 18. At 18, then they've left secondary school. And so it's a bit different how you kind of look at and consider these things. There are also a lot of structural and systemic issues, certainly in the UK and I think in other countries as well, around what we call stratification of science, of the way it's taught, of how you have sort of upper levels and middle levels and lower levels, and it's the upper levels that we're really cultivating and the lower levels not so much. And certainly in the UK, they really have to specialize fairly early, about the age of 14 or so, and decide, okay, are you going to continue with science or move on from it? And then this notion of science capital is also what came out from the Aspires research. So again, just to kind of repeat, students really, they do like science. They think it's interesting. Their families think it's important. They have a lot of respect for scientists, but this isn't translating into aspirations to be a scientist. And of course, we don't want everyone to be a scientist. That would be an absolute mess. But the discrepancy between their attitudes toward science and the aspirations, or what we call the kind of doing-being divide, they enjoy doing science but don't want to be it, is really striking and has stayed, very much unchanged over the years as they get older. And so a lot of our work, we've tried to explore what's going on, what might be the reason behind these patterns, and also what we might be able to do about it, if anything. So one of the things, also just going back to this previous slide, not only does the proportion not change a whole lot, but who it is who's in there doesn't change a lot. The people who aspire to science tend to be from socially advantaged families. In the UK, at least, they tend to be white or from South Asian backgrounds, generally male, again, middle class kind of advantage, and oftentimes have parents who have STEM qualifications or work in STEM. And now a lot of this comes, as I said, from the Aspires research, which is based in the UK. And we necessarily had to look at science more broadly. As we got older, we were able in some ways to break it down more specifically into kind of biology, chemistry, physics. But you can't realistically have a survey that's 6 hours long. So you kind of had to balance that. But from what we can tell, certainly a lot of what we're seeing in these sort of the doing being divide in who's holding these aspirations, it tends to be exaggerated even more when it comes to physics and associated with that astronomy. And a lot of this also seems to be applicable to 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 uh, to Europe more broadly, just beyond just the UK. So why do we care? Why is science participation and science aspirations, why is it an issue? And there's the perpetual concern particularly among policymakers, but also among other establishments, even within the school system and certainly within the academy, about leakages in the pipeline and, oh, we're losing people and there are not enough people who are going into it. From the perspective of our research, we're not as concerned about that, simply in that in the UK, at least, there seem to be enough people. It's just what those people look like and who we are losing. And we're losing a lot of the diversity. And there's so much research around the value of having diverse perspectives for science. It's been certainly in the media here a lot lately, and I think other places as well. We also see science as both a social and personal good. It benefits society in many ways. I mean, this has obviously really stood out more with the COVID crisis, and also a personal good, both in terms of accessing good jobs and also just the way people might engage with issues in their lives and feeling like they can do something about that they might be able to leverage certain knowledge and skills to address concerns that they might have. And so we see these inequalities in science participation as really going beyond just serving the pipeline, but really being an issue of social justice. And here I keep talking again about science very broadly, but again, this includes astronomy and space science. And one of the things, though, that also when we think about things like COVID, there are challenges. One of the many challenges around astronomy that we can get into more is that although it tends to be very exciting and interesting, it's sometimes people can have a harder time seeing the relationship between that and their day-to-day lives. And I'll touch on that a bit more later, but sort of they're comparing it to, say, medical research. And I'm not saying this to be kind of difficult or provocative, but to just sort of flag some of the challenges that astronomy can face. So what does shape science participation? And it's a lot of the things I've been talking about. It's family and background factors, gender, ethnicity, social class, geographic location, age, all sorts of things like that, as well as their experiences of school science and the education system more broadly. And one of the things that's come out a lot, and I don't know if you're touching on this much today in the other talks, but things around careers education and how these sorts of choices are talked about and encouraged, and what's talked about, and how that takes place. And then there's everything that goes on outside of school, the media, things they encounter there around images of science and popular representations of that, community spaces, everyday informal science learning settings. It can be anything from maker spaces to hands-on science centers to just other clubs where they might do a bit, community settings, and so forth. And again, this issue of science capital that I'll explain in just a moment. And one of the things, though, I want to touch on, because I think it's particularly relevant here for astronomy, is this sort of, I think in the first talk, it looked like you were talking about astronomy as such, and I'm talking here more about astronomers and the perceptions of both the science and the people who do it. So who it's for, who does it, and who can engage with it. And so one of the things that we notice is, and I'm not sure if I'm sure you recognize Einstein. I don't know if you recognize Brian Cox, who is a very famous scientist here in the UK. He is a physicist and astronomer, and is also, so he's an academic researcher and does a lot of science TV programs, and was famously in a band in the 80s, I believe, called DREAM. And then Carl Sagan, and from uh, the TV program that I'm just spacing, but it's Sheldon from the one set in Pasadena where they're at Caltech. That's embarrassing. Anyway, and one of the things we find is that the media representations of scientists are really having an impact on what people think about science, who it's for, because a lot of people aren't necessarily encountering scientists in their day-to-day lives. And one of the main things that this comes out for is this whole idea of science and scientists as clever and as brainy. And so for a lot of people, they see science as something that is associated with masculinity. It's males. In this case, looking at the pictures, it's males, it's white males, it's very, very clever white males. That's who does science, particularly physics. And at the same time, they're very powerful and respected. They make a difference in the world, but it's all kind of combining to, and I would not disagree with that, but it's all kind of combining to have this certain image that sends a message that science is difficult. You need to be clever to do it. And so it may not be for me. And this, again, is especially the case for both physics and astronomy. And I think that's really worth bearing in mind. What impressions, when you're teaching these topics, when you're teaching this subject, what impressions might students have of who astronomy is for? And it's sort of this juxtaposition between who it's for, like who's interested in it, and then who belongs in it, who does it, so who practices it like in their work. And there's some really interesting issues there around the breadth of people who are interested in it and who find it interesting, and then what the people look like who may actually work in this. And I also want to mention another piece of research that I was involved with that looked more specifically at astronomy and space science and perceptions of this. And it was called Space Awareness, which was a Horizon 2020 project that ran for 3 years, 2015 to 2017, and aimed to inspire students with space science and about space science, and to try to sort of encourage careers in space science and support this. And it's led on to further projects that are all kind of in this same vein. And for this project, we did a survey, excuse me, of pupil attitudes to space science, but there have been similar projects that have maybe in the course of creating interventions or activities and evaluating them have asked similar questions and found similar things that reinforce this. And that was a survey of just under 8,300 pupils across 11 European countries. The kids were ages 10 to 15 roughly. And we found, quite frankly, about what you might expect. There was a lot of enthusiasm for space science, a lot of positive attitudes around it. So who it's for from the perspective of interest, and this lines up with the Rose study as well, that was done several years ago. There are lots of people interested in this. And we know that, and that's a big plus. And at the same time, when we're talking about careers and who aspires to careers in space science and who they think might be able to work in space science, girls are a lot less likely to express aspirations for this. So who it's for in terms of who does astronomy, again, it's the males. So that's the issue that we're grappling with. And so where does science capital come into play? So because I can't see the room, I don't really know. But I don't know if people have actually heard of this term before or not. It's definitely situated within kind of the science education research over the past, I guess, 10-ish years or so, or maybe 8 or 9. It kind of really started emerging about the time my son was born. And so science capital is a concept. It's a way of encapsulating or bringing together all of the science-related knowledge, attitudes, experiences, and social contacts that an individual may have. And it really draws on, there's a French sociologist named Pierre Bourdieu, and it draws on his ideas of capital and cultural capital. And we're really looking at that from sort of within the realm of science. In particular. And one thing that really stood out for us was that in those massive surveys that we were doing for Aspires, we were finding that some of the patterns we were expecting in terms of who aspires to science weren't as clear cut. So we thought, well, there's something else going on here. And although there were certain things that were similar, it wasn't as clear cut as we thought. So we started looking more closely and came to realize that it was this, group of science-related knowledge, attitudes, experience, social contacts, et cetera, that really seemed to relate even more strongly to aspirations. And we found that the more science capital a person has, the more likely they are to aspire to and participate in science, like particularly when it's non-compulsory once they've been able to stop studying it at school. So either continuing with it academically, or using a job going for a job that uses it, or simply engaging with it as they get older. They're more likely to participate in it and to have what we call a science identity, feeling like science is for me, that other people might think of you as sciencey. And I think so that's really kind of what that is, and that was what we really started to look at and try to kind of focus on. So to get into it in a bit more in slightly more detail, it really has kind of four main categories: what you know, or science literacy; how you think about science, kind of attitudes and values; what you do related to science, particularly outside of the classroom, but also in school as well; and then science at home, or connections, who you know. And again, that comes from the Aspires research, but a lot of this also we see replicated when you're thinking about physics and astronomy, and being applicable outside of the UK as well. Now, just a warning, because this is going to be a kind of slide with a lot of words coming up by the time I'm finished with it. But we statistically, via the surveys we were looking at, broke this down into sort of 8 more detailed dimensions of science capital. So there's science literacy, which also includes confidence and feeling that they know about science; science-related dispositions and preferences. And here we're really talking about the extent to which an individual sees science as relevant to their everyday life. And I think that's, as I mentioned, one of the challenges around astronomy, seeing how that might help them address a concern that they have in their daily life. Symbolic knowledge about the transferability of science. What we're talking about is how science qualifications might be valuable for a range of jobs. Consumption of science-related media, books, TV, online; participation in out-of-school learning contexts, visiting science museums, zoos, and so forth, or science clubs; family parental science knowledge and qualifications. So again, that comes back to who you know and what they know about science. And again, related to that, knowing people, sort of, and by what we mean in a meaningful way is, it's not just somebody, oh yeah, my neighbor down the street who I never talk to, but family, friends, peers, people who work in science related jobs, but people who you might have conversations with in your day-to-day life. And then again, it's those conversations. So it's sort of a lot about the extent to which science is part and parcel, woven through your everyday life, woven through the everyday life of children, not in a way that we as adults can say, of course it's there, and we can talk forever about all the important ways that it's there, but that it really is a part of who they are and what they do on kind of a day-to-day basis. So that's very well and good, but how might we put some of this into practice? What can we do? And so again, as part of this overall group of projects, and particularly the Enterprising Science Project, the research and development project that I mentioned, we developed something that we called the Science Capital Teaching Approach. And this was developed with about 43 secondary school science teachers over a 4-year period. We kind of co-developed this approach, and we had 2 trials, each of which were about a year long. And it was really kind of a professional development type model, which I think taps into some of what you're talking about today, or one of the sessions today at some point kind of touches on, where there were a couple of Saturday sessions and then regular ongoing support, visits to schools, observations, discussions, and the data collection took place over a whole academic year, as well as involving, interviews with students and some surveys and that sort of thing. So it was very thoroughly researched. And there's also now, and I didn't get a chance to grab the screenshot of the cover, there is a version developed for primary school, which is available online as a PDF. And so essentially what we're talking about is there's this kind of foundation of good teaching. Here, this is the kind of diagram for primary school, but it's almost identical for secondary school, and talking about the foundation of sort of changing what counts, like what is valued, and ways to do that. And it's all, though, based on just good teaching. It's not something brand new that we're advocating for, but how to go about making what you do, ways you can tweak it to make it more relatable to the students, and reflecting on that process. So we'll get into some of these details. So in terms of that foundation of, for example, tailoring to the least engaged, it's all connected to what we call broadening what counts as science. And people sometimes have a bit of a hard time getting their heads around what exactly we're advocating for. And where this comes from is that students not only find science concepts difficult, and again, think about physics and astronomy, but while they might find it interesting, at the same time, it feels very alien to them, very far away, distant, which astronomy, certainly is in many ways. But what we're arguing for is to really change the field, change how it's taught, change what you're doing, rather than, it's not about changing or fixing the individual. It's not this sort of trying to move away from this deficit model of saying, oh, we've just got to pour in this content, but rather how that content is discussed, how we're interacting with students. And we really want to challenge those stereotypes. Think of those pictures and the dominant ideas and representations of who does science and what counts as doing science. So opening up more ways that individuals can be recognized as doing science or being scientific. So if you think about, like, in a classroom, in order to be like a good science student, who's valued as indicating a good pupil, someone who's always got their hand up and visibly engaged that way. But what about the shy kid? What about that child who really wants to sort of sit and think about it and that sort of thing? Is that valued too? What about the child who wants to bring up something that doesn't necessarily seem as related, because it's something, even though maybe in their head they're starting to relate? So we want to kind of think about that, and how, that's what I mean by how are we interacting? How are we approaching this? And challenge this dominant idea that STEM subjects, science, and again, particularly when it comes to physics and, related to that, astronomy, are only for the really clever kids, or only for boys, and sort of trying to challenge that, I think, is a particular thing when it comes to astronomy and physics, and tying this back to these ideas of it's for boys and of masculinity, and this whole notion, I don't know if you've come across this before, of what gets called effortless brilliance. Oh, they can just do it. They don't have, Sheldon, again, in the TV program that I will get back to. But anyway,
The Big Bang Theory.
Thank you, The Big Bang Theory. Thank you. Trying to torture me. I watched pretty much every episode of that program. Thank you. So again, it's like, ooh, you have to be super duper clever to do this sort of thing, and you should just sail through it. So that's kind of what we're up against. And then some of the approaches that, again, form part of this foundation, and how you might go about this, really involves things like tailoring to the least engaged, thinking about your pupils, who seems not to be engaged, and how can we make it relatable to them? It's not just saying, focus, pay attention, but are there things we can do? And start, instead of necessarily starting with the objective, which is what we always do, but kind of think about what they might already know about the topic, or what they might have experienced in their own life, and how it might relate to their lives and what's important to them. Again, particularly more challenging for some areas of science than others, but that's the challenge to you. and leveling the playing field, sort of, again, creating this classroom where young people who aren't necessarily from certain backgrounds aren't overly disadvantaged and kind of value wider ways of participating. And again, supporting the voice and agency of the student, creating this classroom environment where their voices are heard and validated. And that can really help them develop this sense of ownership or agency towards those topics. So a bit more specifically about what we can do is we talk about personalizing and localizing. And this one, it sometimes has taken our teachers a while to kind of get to grips with it, of the idea of going beyond contextualizing it and making it relevant to your students' everyday lives. And it looks different every time because people are different, your students are different, but really trying to locate it in examples and experiences from their own lives. And this is no small task, especially when it comes to things in physics, astronomy, and space science. And some of our teachers found that there were topics that they just struggled to make those connections. But where you can try to, and bear this in mind. So, for example, there might be possibilities. There was a science fair where students were talking about astronomy, but were really relating that to sort of cultural myths related to the stars and that sort of thing. So there might be some connections related to that, related to history, who the ancient astronomers were, taking that kind of perspective. And the space awareness kind of tried to look at that as well. And there are a lot of people, for example, who do find astronomy interesting, because it is interesting, but maybe taking some time to explore who in particular is interested. Is there anything they do about that? Do they watch some documentaries on TV? Did they see this documentary that was on the other night? So rather than just saying, oh, of course they find it interesting, how does that get practiced? How does that get enacted? But really in supporting engagement, not just in astronomy, but just in teaching generally. And this is where we're saying this isn't that new. Educators really, it's very helpful to have an understanding of your students' personal interests and lives and communities and values, and taking the time to get to know them. And likewise, from sort of a policy curriculum standpoint, trying to allow for that to happen, allow space for that, as opposed to sort of trying to ram in so much content, which is certainly a problem here in the UK. And again, a key example when we're talking about astronomy or anything else, a lot of teachers would say to us, oh, well, yes, of course we do this, because when we teach a topic, we talk about the jobs that this could relate to. And while a student can't aspire to a job that they've never heard of, it's a bit tricky on that. But at the same time, there's something to be said for finding out what it is students want to be when they grow up, what they're hoping to do, and trying to tie the content to that, go in that direction. And another way that you really can start to do this is something that we call elicit, value, and link. And it's a way to support pupils to feel valued and connected to science. So it's eliciting the experiences and skills and home values, the things that they bring with them. And you're effectively then creating that environment where that's okay. There are different ways to engage, to participate. It's not this one size, one type of student fits all kind of purpose. And elicit that in relation to a topic, value that, legitimate that. So it's not just, oh, who's heard of this before? Yes, great, move on. But if somebody starts to relate an example, to sort of feel comfortable in taking a few minutes to say, oh, well, that's interesting, and I can see that, and what makes you talk about that, and tell me more, and reflect that back to the class, and then highlight those science connections. So you're linking what they bring to the content that you're trying to talk about and cover. And again, building the science capital dimensions. I apologize for the scary nature of that slide, but it does sometimes work to have all 8 together, and to really kind of think about them in planning. And are there ways that we can bring that in, building that understanding of how science is everywhere, which certainly is the case in the UK, but I would imagine it's similar in Sweden, where students can parrot, science is everywhere, science is, and they do think that, but how that pans out in their daily lives, how they really get to grips with that deeper understanding, a lot of students who don't have so much science capital, who don't come from those backgrounds, that's more challenging for them. So fostering that sense that either science isn't hard, but you can get there by breaking it down if you keep going, that sort of thing. You are capable of doing that. It's for you. It's not only for other people, and it can be a part of our family's life and conversations. So it is really tricky because a lot of concepts in physics and astronomy are hard, and you don't want to give people the wrong impression either and say, oh, this is going to be easy. And then if they find it challenging, think, oh my gosh, this actually isn't for me and I'm out of here. So managing all that is certainly a challenge. Mm-hmm. So I guess kind of wrapping it all together, to kind of recap, I'd say that increasing interest and inspiration isn't enough. We need to go beyond that. And in fact, when it comes to astronomy, I'd say it certainly isn't enough because they're already there. Loads of people find stargazing, find astronomy. I could sort of see on the screen the kind of pictures from, I think I heard James Webb mentioned. They're amazing. And you can, people are inspired by it. People are interested in science generally, and certainly in astronomy. But we need to think beyond that and sort of build their resources to engage with it further, to engage with it beyond the interest and inspiration level. As important as that is, and we don't want to neglect that and say, actually, we're wrong, it's really dull. That just makes no sense. And then classroom teaching, as well as enrichment, any extracurricular activities you provide, clubs, all of that offers potential, but we really want to dive into kind of how you approach the topics, how not so much, well, I mean, you would certainly also consider how, explanations that are given, but it's those interactions with the students that are so key in them feeling like, oh, I can understand these complex topics. I can get to grips with this. It's hard, or it might be hard, but I can do this. And these sorts of equitable changes in your teaching can support wider and deeper engagement with the subjects and with the topics, and take it that much further. And as I said, I wish I had the answers. I have some ideas that I've talked about, but astronomy really, in particular, has these challenges of balancing awe and wonder. I don't know if there's a comparable phrase in physics. It certainly gets, in physics and in Swedish, but it certainly gets used, awe and wonder, in the UK, talking about astronomy in particular. It is very inspiring, but balancing that with making it accessible, making it relevant, and helping it, presenting it in such a way that it feels relevant to people's everyday lives, is an ongoing challenge. And I would love to say, and I've solved it, and here's what you do, but I haven't. All I can do is continue the discussion. And so we hope, though, that some of the ideas that I've been talking about might help you to sort of achieve that balance. And I have sent my slides to Peter, so I'm hoping that can be circulated, because we have lots of resources and things you can look at, and that sort of thing. And so, you can, if I had thought about it, I could have put a QR code for this on this page or something, but unfortunately that just now occurred to me at the moment. So hopefully, though, that can be circulated, or the links circulated, because there's a lot out there. And with that, Q&A, should I continue screen sharing? What should I do?
Yeah, you can do that, Jennifer. Just leave it on.
Just leave it on? Okay.
Yeah. This is fine.
Okay.
So, Jennifer, thank you very much for this very interesting